Okay, everybody, it's 11 o'clock, let's get started. No matter how important your conversations are, please wrap them up and find a seat if you're just coming in. Okay, so I'll start off with a bit of housekeeping. One small reminder, if you have a question for me that only pertains to you, send an email. But if the question pertains to everyone, for example, if it's a question about the test, like not your specific test, but about the test in general, or about course content, please post it on course questions. That way I can answer it once for everyone. One small semi-piece of housekeeping. So I sometimes watch the lecture videos to see if I made a mistake, and I misspelled heritability pretty badly on one occasion, which is kind of ironic. I was lecturing on intelligence. That's not a really good look. I told my supervisor that, and he had a good laugh. Go with the spelling that's in the key terms. Additionally, I forgot to show one video, and I forgot to mention one theory, so I'll just quickly do that. You won't be tested on this, but with regard to the section on neural correlates of intelligence, the leading theory now, because what the book talks about is brain size, but not all regions of the brain are equally important. The region of the brain that is most important is the cerebral cortex, which if you took 104, that will not be surprising. But in particular, the frontal and parietal lobes seem to be especially important. If you give someone an fMRI while they're doing various cognitively challenging tasks, I mean, you can even scan their brain while they're doing an IQ test, you tend to find more activity in the frontal and parietal regions, and you find that increased size in these areas is strongly correlated with intelligence, more than other areas. So the leading theory now is called the, I forget which letters first, let me make sure I get this right. The parieto-frontal integration theory, or PFIT. So the idea here is that it's connections between the frontal and parietal lobe that do the lion's share of the work in solving cognitively difficult problems. I won't test you on that, but that's something interesting if you want to go on into the neuroscience of intelligence. Additionally, there's a video I forgot to show about test bias. This is kind of a lighter note, and that's a Seinfeld episode where George Costanza decides to cheat on an IQ test, and something happens, and the possibility of test bias is brought up as a possible explanation. So I'll let the video speak for itself, and then we'll go from there. Okay. So the only reason I was going to show that was to use it as a possible example of what bias would consist of. So Jerry jokingly says, oh, and by the way, she gets 151 when she does it again. I forget why. There's some plot twist where the test was scored incorrectly or something. Not that matters. But if you really did have a test that only consisted of things that men were much more likely to know, that would be prima facie evidence of test bias. But as we saw last time, the way you can quantify it would be to look at whether it had what's called predictive bias. Right? Just look at, does the test predict grades for men and women equally well? And if it really did just have questions that only men would know about, probably it would predict grades better for men than it would for women. So mostly just a lighter note, but it is an illustration of that. So as I say, Elaine does better the second time. Okay, so that's all I have to say about the stuff we didn't get to last time. So let's start where we finished, which was sex differences in cognitive ability. That's the next section. So as I've mentioned, I think a few times now in passing, there is no average difference between males and females in IQ scores. It works out to 100 each. that's the average. You'll find some where there's a slight advantage for men, some where there's a slight advantage for women, but the studies kind of cancel out. The average is roughly 100 for each. However, if you zoom in on the subtests, you do find some differences. They are not especially large, but they are consistent. This is not just one or two crazy studies. There are massive meta-analyses finding that on some of the subtests, there are advantages. Some of the advantages go to males and some go to females. For females, the book mentions some IQ subtests, but also just some abilities, just some general abilities. One is object location memory. So a bunch of objects are put in different places, they're hidden, you have to remember where they are. You can give cognitive tests like this. Women do better. Another is verbal fluency. This is a commonly used test where you say, okay, write down as many words as you can that start with the letter Z, letter F, whatever. Women tend to get higher scores on that. Perceptual speed. So you're shown two patterns. You have to quickly identify a difference between them. They're faster at calculation. So if you're not like a word problem, but just like a calculation, like 37 times 22, you have to do it in your head. Women tend to do it faster. And the book mentions one physical ability, which is fine motor dexterity, so skill with manipulating small objects. Women are on average better. And the things I said about the ethnic group differences apply here too. These are only on average. It's not like every single woman will be better than every single man on these tests, but you do find an average difference. For males, one that's been widely studied is mental rotation. So we looked at that back in chapter 9. So how quickly they can mentally or spatially manipulate objects in their mind. Men are better at that. Men are better at mathematical word problems. So I never understood why this was the case, but this is, again, very well replicated. Women are better if it's just a calculation, but men are better if it's a mathematical word problem, like some real-world example that you have to use to solve it. Men are better on average at spatial navigation, and unsurprisingly, better at throwing. That's one physical ability that talks about. That difference is quite large. So, as you might expect, there's a debate about what explains these differences. And here, my suspicion is there's a contribution both of genetic and environmental factors, though that remains controversial. So for example, one idea that's been looked at is in the case of mental rotation, men are socialized to do different kinds of tasks. For example, video game playing actually improves mental rotation. They once did a study where they had women play video games for a certain number of weeks or months. I forget the details, but it did close the gap to some degree. So the kinds of tasks you're kind of raised to do can have an effect. Evolutionary psychologists have made some conjectures about what the function of some of these might be. So the standard account is that when we were hunter-gatherers, which is most of our evolutionary history, men did more of the hunting and women did more of the gathering. So something like throwing quite obviously could be helpful if you're the hunter. And some have conjectured that some of the psychological differences could also relate to that. That's a little bit more conjectural. It's kind of hard to test an explanation like that, but the book has a brief discussion of that as well. There are also some studies looking at possible hormonal contributions to the differences. For women, the level of female sex hormones changes over the course of the cycle, and there is some evidence that's consistent with those also playing a role. Like you can look at performance on the tests across the cycle. I won't say too much more about that because I'm in enough trouble already, but the book has a discussion of that as well. One difference that the book does not talk about, but could also be, or one that could also be consequential, is the difference in variability. So as I mentioned, there's no evidence, or no good evidence of an average difference in overall IQ, but there is evidence for a difference in variability, meaning how many men and women there are at different levels. Or another way of saying that is, how wide is the distribution? This comes from a study in which every 11-year-old in Scotland was given an IQ test, so very large sample. And the hollow dots are what percentage of men occupy that particular IQ score, and the black is what percentage of women. So if you zoom in, there's still fewer men and fewer women at the extreme. So here there's 277 and 203, but there's thousands of men and women in the middle. So the y-axis is what percentage of people at that IQ level are boys versus girls, but you find a very orderly finding where there are more males in the tails at the very high end and very low end. The way it works out is from an IQ of 50 to 60, around 60% of people at that IQ level are males, and for IQs of 130 to 140, also around 60%. And here again, there are some evolutionary explanations. Biologists since Darwin have found that, not just in humans, but in other species too, males tend to be the more variable sex for different things you can measure. I won't go into the details there, but there are conjectures that have been put forward from biologists. It has to do with things I talked about in 104, having to do with parental investment theory. Okay, the only other thing I have to say, this is not intelligence per se. Maybe you could characterize it as stupidity. It's risk-taking. There is a very large sex difference here, wherein males are significantly more risk-taking or significantly less risk-averse, however you want to say it. And one of my favorite examples of this is the Darwin Awards. How many of you have heard of the Darwin Awards? Maybe 20 people. So this is kind of a cruel website in a certain sense, but if you have kind of a dark sense of humor, it's very amusing. So the awards are given to people who die doing very stupid things. They don't actually send awards, they just post like a blog about it. So one example, there was a guy who was trying to clean his chimney. So he attached a brush to a chain and was lowering it into his chimney to clean it. But the brush kept getting caught on the way down. So he thought, I have to attach something small and heavy to the chain so it will go down and not get caught. And he thought a grenade would be a good choice. So he tried, because grenades are small and heavy, so he was onto something. But his method for attaching it to the chain was to use a welding flame to bind it to the chain, and well, he didn't make it through that experiment. So why am I bringing this up here? People have actually done analyses of the Darwin Awards. The winners are almost always men. So another way of saying this, it's not the case that women are smarter than men, but men are dumber than women. That's my take. Okay, so that's all I have to say about the sex differences section. Any questions on that?
Do you think that being transgender has any sort of effect on this, being that your brain is made how you're biologically born, but if you take hormones, then your hormones change. How does that affect you?
Yes, I know of one study, small sample size, but they looked at regions of the hypothalamus that are highly sexually dimorphic. So there's regions of the hypothalamus where the size is very different between men and women, and they looked at transgender people, and I believe it was the case that they had size for those regions that was more similar to the sex they identify with than the sex that they're born as. But I don't want to say more than that. I don't know about measures of performance on cognitive tests, if those are more consistent. That's the only thing that comes to my mind in the Google that I have. It's an interesting question. I'm sure someone's looked at that. Yeah.
About the calculations advantage and like the word count, is it like just about speed or accuracy or both?
Oh, that's a good question. I believe in the calculation case it's about speed, and the word problem when it's about accuracy, but I'd have to double check. And I won't test you on, the individual. All I really want you to know is there's no average difference overall, but there are differences in subtests. I'm not going to get super specific on the test. Other questions? Okay. Last section for chapter 10 is on extremes of intelligence, so being very high or very low and what that is associated with. The conventional way of defining being very high or very low is being above 2 standard deviations above the mean or below 2 standard deviations below the mean. So over 130 or below 70. It's kind of arbitrary to put it there, but that's kind of the conventional way of defining it. There is a typo in the book. It indicates that 10% of people have IQs of above 130, and I don't know how that got in there, but that is not true, and it's not controversial. It's around 2%. This is a good reminder, to not take what the book says on faith, and to not take what I say on faith. Everything that humans make is fallible. That's a good scientific attitude to have. Always be skeptical. But around 2% of the population has an IQ of above 130. And I want to say something about the relationship between high IQ and performance in cognitively demanding situations. So there is a relationship, like I said last class, between having a higher IQ and doing better at cognitively difficult jobs. But one interesting finding about this is that higher IQ tends to have diminishing returns, meaning after a certain point, it starts to matter a lot less. The difference between 130 and 100 is a real difference. The difference between 130 and 160 sort of has diminishing returns. One analogy that's been given for this the relationship between IQ and success at, let's say, graduate school or law school or what have you, is similar to the relationship between weight and success in football. So, in order to have an easy time in graduate school, it definitely helps to have a higher IQ. If you have a lower IQ, it's not impossible, but it will be challenging. But past a certain point, it kind of stops mattering very much. It's other traits that make more of a difference. Something similar is true for weight in the NFL. If you want to be a lineman in the NFL, you kind of have to be a big guy, right? If you're 130 pounds, it's going to be pretty tough to be a good lineman in the NFL. But if you look at people in the NFL, there's not a very strong relationship between how big you are and how well you do. As long as you're above a certain threshold, it kind of stops mattering. Yes?
How does IQ vary over like a lifespan?
We're going to talk about that in chapter 12. The short answer is crystallized intelligence, so like vocabulary, information, things like that, tends to stay pretty constant after the 20s and then go down maybe like 60s and 70s. But fluid intelligence starts going down in the 20s to 30s. So how quickly you can solve problems, kind of how agile your brain is, that starts going down pretty early. So my fluid intelligence is as good as it will ever be. It's all downhill from home. So anyways, so that might be a helpful analogy. So like I was saying, once you're past 200 pounds, 250 pounds, being heavier does not make much of a difference, and the same is true for IQ. And I have one concrete example, and I don't think these people will mind me saying this. I mean, I won't name them. But there were two graduate students in my master's program in Georgia State that I was very close to. The three of us traded master's theses and helped each other refine them. One of them was like super smart. He got a perfect score on the GRE verbal. And that's a test just for people applying to graduate school. It's a very hard test. And he got perfect. When he told me that, I was like, you bum. But the other guy was, smart enough to get into the program, but he was not as quick as the other guy was in debates. Because in a master's program in philosophy, the way that you socialize and bond is by arguing about topics that don't matter. That's how you get close to other philosophy students. And the guy who got a perfect score was quicker. You could tell he had a better mastery of facts and was kind of better at thinking on his feet. But the other guy was a much better graduate student. And the reason was he just worked way harder. When he wrote his master's thesis, he would go over every word. He would reread it, reread it over and over again until it was perfect, whereas the other guy was kind of happy with the first draft, and that was it. At the end of the program, the other guy had 4 first author academic publications, which that's good if you're finishing a PhD. For a master's, you're lucky if you've done 1. So, no, like I said, he was still smart enough to get into the program, but past a certain point, it kind of stops mattering very much. Okay. So that's high IQ. For intellectual disabilities, as I say, the conventional way of doing it is setting the cutoff at 70. Now, this is from the DSM-4. This is pretty much the same in the DSM-5, but one thing that they've changed is having an IQ of below 70 is not sufficient for being classified as having an intellectual disability. You also have to have difficulty functioning. Like sometimes, if you can live on your own and support yourself and not have any noticeable problems, they won't classify you as having an intellectual disability. So you need both an IQ of below 70 and concrete behavioral difficulties. So as you can see, there's 4 levels. Mild, which is 50 to 70. Moderate, which is 35 to 50. Severe, 20 to 35. And profound, which is below 20. And having a mild intellectual disability is by far the most common. If you look within this kind of pie chart of people who have an intellectual disability, that's the most common. And the causes of mild versus profound tend to be different. So for example, mild intellectual disabilities tend to run in families, but profound intellectual disabilities tend not to. So if you look at the siblings of people with mild intellectual disabilities, they tend to have, on average, lower IQ scores, which is not surprising because, as we saw, IQ is significantly heritable. But profound intellectual disabilities tend not to result from heritability in that sense. They tend to be caused by the mother has a virus or something while she's pregnant with the child, or there's a brain injury, or there's a genetic mutation. So not a gene that's like passed on through the family, but just there's some kind of mutation that results in a problem with the brain's development. And of course, having a profound intellectual disability is much more limiting. People with IQs of 50 to 70 often can lead pretty much normal lives, but people who have profound disabilities tend to need support throughout their life. They, generally speaking, cannot live on their own. One specific cause of intellectual disability that many of you probably heard of is Down syndrome. Down syndrome has a very specific genetic cause, which is an extra chromosome at the 21st pair. So we have 23 pairs of chromosomes. For each pair, there's one chromosome from mom, one from dad. But at the 21st pair, they have 3, where there should be 2. Not every single Down syndrome person will have an intellectual disability. It's just that the whole curve is significantly lower. I think the average is something like 50. Don't quote me on the number, but theoretically, and actually empirically, there are some people with Down syndrome who have normal range or even above average IQs, but the average is much lower. Okay, I think that's all I have to say about that. Any questions about extremes of intelligence?
Is there any relation between learning disabilities and IQ?
Yes, that's a good question. So a learning disability is defined like this. So take dyslexia, which is a really widely talked about one. In order to be diagnosed with dyslexia, you have to have a normal range IQ and difficulty reading. So that it's specific to reading, in other words. If you have trouble reading, but you have an IQ of 55, they wouldn't say you have dyslexia. They would just say, well, you just have a lower IQ. But if your IQ is normal range, but you just have a lot of trouble with reading, then they would diagnose you as having that. But you will not be tested on that. Okay. Yeah.
If you had dyslexia, would it impact your scores on the IQ test if it was like?
Sorry, say that again.
If you had dyslexia, would it impact the scores on the IQ test because if it was like you're reading it?
Well, yes. So I forget exactly how they do it, but what they might do is control for the vocabulary items, because there are a few items that involve language, although a lot of them don't, right? So if you look at like a score on like the matrix reasoning, there's no language involved there. So I assume it would be if they have normal range IQ for all of the other items, but they just have a special problem with reading. I assume that's how they classify it. Any other questions? Yeah.
Has there been like a study done that if like somebody does an IQ test and they receive their score, is their next IQ test would be like lower, or like does knowing your IQ impact your ability to take the test?
That's a good question. I think they're generally reluctant to give test scores to people, and I think they should be. I think they generally shouldn't give people their scores because for this very reason, people will probably obsess over it more than is warranted. I mean, as I've tried to emphasize, IQ is real. It does measure something that can enable you to predict things, but it's, like in the case of grades, it's maybe 30% of the variance in grades are explained by IQ. So obsessing over, oh, I got 97 or I got 83 is probably not a good idea. But to answer your question, I don't know if there are studies like that. You can go on Google Scholar later. Other questions? Yeah.
Is there a percentage for the low IQ, like the high IQ? Like the IQ is
It's around 2% too. Yeah. And of that 2%, most of them will have IQs of 50 to 70. The further out you go, the rarer it gets. Okay, I want to close off this chapter with a little parable. This is one that's commonly used. Because as I just said in answer to someone's question, IQ is real, but it's not everything. If you look at the meta-analyses in the case of grades, it explains, and it depends what study you look at, but maybe 30% of the variation in grades. In some studies, maybe only 20%, which is more than any other test in psychology, but it's still only 20 to 30%. And the analogy that's sometimes used for cases like this is it's a little parable. So there's a guy walking down the street and he drops his keys. It's the middle of the night, so he has trouble finding his keys. And so what he does is he paces around under the lamppost looking for his keys. And someone walks by and says, "What the hell are you doing?" And And he says, I'm trying to find my keys. He says, but you're only looking under the lamppost. Could be anywhere. And he says, look, I'm looking under the lamppost because that's where I can see. That's basically psychology. We are limited to what we can objectively measure. And we do find real things there, but it is a kind of limited practice. We can only look at what we can see or what we can measure using these kind of objective criteria. And therefore, probably we are missing some things. Okay, so that is the end of the intelligence chapter. We'll now move on to the chapter on development. And just to remind you of where we are, so I'm hoping to finish most of the chapter on development this week, but probably I'll have to do a little bit on test review day next Tuesday. Then next Thursday will be test number 2, and then after that it's reading break. So after we finish this chapter, you guys will get a week off to recover or read ahead, depending on your inclination. And then after that, we'll be finishing the book. After that, it's just 13 to 17, so no skipping around in order. Okay, so to start off with, we're going to talk about the different methods that developmental researchers use. And these are the two main ones. There's one third one that I actually didn't know until I read this book. But these are certainly the two that are used most commonly. They're also more likely to show up on the test. Hint, hint. So developmental psychology is about how people change over time, over the course of the lifespan, starting from conception all the way to death. And most of the work is from conception to maybe 20 or something. So that's where the lion's share of the work has been done. And these are two different methods for studying how people develop over the course of lifespan. So let's say we wanted to do a study of how musical taste changes over time as people grow up. And suppose I have the hypothesis that as people get older, they tend to like slower music more. Now their brain slows down, they're not as fast as they used to be, and they like slower music. It's more soothing to them. So not like that. And so let's say I look at musical taste from age 10 to 80. Let's say that's what I'm interested in. So if I was going to do a cross-sectional design, I would get a group of 10-year-olds, a group of 20-year-olds, and so on, a group of every age from 10 to 80, let's say every 10 years, and measure them all at the same time. Just say, hey, how much do you like slow music? And then if I find that the 80-year-olds like slow music more than the 10-year-olds, I conclude aging makes people like slower music more. Now there's a big problem with this method. Can anyone tell me what it is? Anyone want to venture a guess?
Is it too big of a range?
No, it's not that. I would say it's a good guess. But so to say again, maybe think about what's another possible explanation. So I took a group of 10-year-olds, group of etc., and measured how much they like slow music. And I conclude it's because they got older. But is there something else that could explain? I think your hand is up first.
The change in music genres during each of their developmental periods.
Exactly. While they were developing, there were different musical tastes around. Right? The 80-year-olds grew up in a totally different generation. Maybe they like slow music because they grew up in the 50s or whatever it would work out to. And you just don't know. If you use cross-sectional, you can't really be sure if the effect is due to aging or if it's due to when they grew up. So longitudinal, you get one group of 10-year-olds and you follow up with them until they're 80. And you measure how their tastes change over time. So that's a significant improvement because now everyone grew up at the same time. The only thing that's changing is how old they are. So that's a more valid way of measuring it. No, I even noticed generational differences between me and my sister, like huge differences. Like, how many of you know what a VHS is? Oh, okay. How many of you have never seen a VHS in your life? Oh, interesting. Okay, maybe it's not as big of a difference as I thought. So I grew up with VHS. Okay, most of you know what that is, but my sister didn't, and she would be college age next year. And she is significantly less patient than I am because she's grown up with TikTok. So her attention span is like 10 seconds. When I try to watch movies with her, it's impossible. She gets bored very quickly. So when you grow up, it can have a big effect. Oh, I forgot to say, I did add some key terms to chapter 12. So the way it'll work from now till the end is, I record the lectures for the week, and then I may add key terms as I do that. I think I said last week that I won't add any more. What I meant was I wouldn't add any more to chapter 10. Like I'll add as I practice the lectures. But there will be no more to chapter 12 because I've finished my practice run through the chapter, which means there will be no more before the test. So just wanted to flag that. Okay, the last method, which as I say, I actually didn't know this existed, is sequential. And sequential is basically doing multiple longitudinal studies. So you get a group of 10-year-olds, group of 20-year-olds, group of 30-year-olds, and you follow all of them grow up as they grow up and see how they change. I would worry more about the first two, but that's what the last one is. So I've said what the main advantages of the last two, because they're both pretty similar. The disadvantage is they are an enormous pain in the ass to do, because they take decades to finish. Sometimes the researcher dies or retires. You got to get someone else to finish it. Like that happens with these studies. People have to take it over. Whereas the cross-sectional, you can do it like in a month, just like a normal study. So that's the trade-off. Okay, we have to briefly review the stages of development inside the womb. We're not going to go into a ton of detail. This is mostly review, probably from other classes that you've had. But the book does the full range, so it goes right from conception to death. So we start with conception. The first stage is the germinal stage, in which it starts as a zygote. A zygote is a fertilized egg. So sperm hits an egg, when a man and woman love each other very much, a baby is created. Actually, funny story about that. As I was practicing, I remember how I first learned that's how babies were made. This is a real story. I was already a scientist when I was a kid, I just didn't know it. And I had noticed that I had things in common with my mom and my dad. And I was like, why is that? Like, Dad just lives here. He's fine, but like, why would I be similar to him? So I asked my mom, I was like, I came out of your tummy, why am I similar to Dad? And she was like, well, Dad gave the seed or whatever. And I pictured him going to the store and buying the seed. And I was like, why is the seed like him? Anyone can go buy the seed. So, then they had to explain. I was like, oh, that was not what I was expecting. Anyway, so when that occurs, the zygote is made. That stage lasts from conception to about 14 days, so about 2 weeks, at which time it's an embryo that binds with the uterus. This is called the embryonic stage. That lasts from about 2 weeks to about 8 weeks. And after the 9th week, all the way until birth, is the fetal stage, in which we call it a fetus. Those are the 3 main stages of development in the womb. And it is during this development that primary sex characteristics are generated. So, whether you are XX or XY, typically determines what your physical sex presentation will be. And the way it works, as you'll know if you took 104, the fetal body's default is to make the body female. That's the default. And then what happens is the Y chromosome triggers the release of testosterone, which then masculinizes the fetal body. One of the reasons we know this is there's a really interesting condition, which I won't test you on, but it just reinforces what I just said. The condition is called androgen insensitivity syndrome. Androgen meaning male hormones, so including testosterone. What that means is the body cannot process testosterone. So these are people who are XY, so they have male DNA, but their body cannot process testosterone, and like I just said, the default is make the body female. So it looks totally female, head to toe. You would have no indication that that it had male DNA. And they don't do a DNA test, because why would you? Baby's born, nothing seems to be wrong. You notice something's wrong when they hit puberty because they don't get periods. Where the ovaries should be, there are actually testicles. That's what these people have. And they present as very feminine, because women have some testosterone, but these people functionally have none, because none of it gets processed. So they typically are, if anything, more feminine on average than the average biological female. So anyways, that just reinforces the point that the default of the fetal body is to become female, and it's the Y chromosome triggering testosterone release that masculinizes the body. Now, fetal development can be harmed by various things that fall under the heading of teratogens. Teratogen is a very broad term, and it includes anything, any environmental agent or stimulus that harms fetal development. So, if the mom gets the flu, if she ingests something bad, virus, anything like that can damage or harm fetal development. Or it mentions if the mother has a sexually transmitted disease like HIV/AIDS, that can harm the fetus. Sometimes it even gets passed on. Of course, one widely studied teratogen is alcohol. Consuming alcohol while you are pregnant can lead to the baby having fetal alcohol syndrome, which is associated with various problems, including a smaller brain size, lower IQ, various social and impulsivity issues. And there's been some people who have argued that there's an evolutionary reason why women are not, I'll say it differently. Typically, foods or substances that tend to harm the fetus, women tend to be averse to during pregnancy. There have been studies of morning sickness, the kinds of foods, because as many of you know, I'm sure, when women get pregnant, they become very picky about what they want to eat. And there have been studies that have found that the foods that women tend to be more grossed out by are exactly the foods that are more likely to make you sick. And this has a possible and quite obvious evolutionary function. So why isn't there the same thing with alcohol, at least to the same extent? And some have conjectured that it's because alcohol is a very recent invention, and we've not had as much time to adapt to it. Whereas, raw meat has been around for forever, as far as humans are concerned, and there often is an association with morning sickness. Yes.
So I presume that would be related to cravings, but why do cravings get so specific?
As far as why cravings get specific, I'm not sure. I'm not sure if anyone's made an argument there. What I'm familiar with is them looking at what women are averse to, what they get grossed out by or sickened by. And it tends to be exactly the foods that are more likely to make you sick, which makes sense. On a lighter note, I was once taking an abnormal psychology class, And so the professor talked about fetal alcohol syndrome and said, look, like if you're ever pregnant, don't drink, it can lead to problems for the baby. And someone asked, and to this day I don't understand what they were getting at. They were like, well, I don't get it. Like, they tell mothers not to drink while they're pregnant, but they never tell the fathers not to drink. So, I don't know. I never understood that. Anyway, so that's all I have to say about teratogens. Any questions about that? One thing that there are references to in the book, but not a grand list, is baby reflexes. So I finished everything I want to say about fetal development, so now the baby is born and we'll start looking at stuff that happens after that. So these I just added to the key terms, so if you have the key terms list from before yesterday, you can add these. There are 5 you should know. The rooting reflex, the sucking reflex, the grasping reflex. The first 3 are pretty straightforward to memorize. And the 2 that have weirder names are the Binsky and the Leroy. So these are reflexes that you can check for to make sure that the fetus has developed normally. If some of these are off, that's kind of a bad sign. So rooting, if you touch a baby's cheek, like a newborn's cheek, it will turn its mouth to whatever touched its cheek. This is to facilitate breastfeeding, as is the sucking reflex, which is anything you put in the baby's mouth, it will try to suck it. And the grasping reflex, again, pretty straightforward. If you put anything in the baby's hand, it will instinctively grasp it. The other 2 are named after, I believe, the scientists who worked on them. And I'll show videos of those. So the Binsky is just when you stroke the baby's foot, there's a very particular pattern of spreading the toes. And I'll show an example of that. This is a fun chapter to teach. Lots of cute baby and kid videos for this chapter. Okay. So those are the reflexes. Now, an interesting question that we care about as psychologists is not just how the babies behave, but what they're thinking about. And inconveniently, babies do not talk, so you can't ask them what they're thinking about. But psychologists have some subtle methods for getting at what they're thinking about. One really simple method that the book mentions is the preferential looking procedure, which is pretty simple. You just show babies 2 things and measure which one they look at longer. So you can measure what babies prefer to look at. Here's one really simple one. If you show babies these 2 shapes, they much prefer to look at this one. Can anyone guess as to why? It looks like a face. And that generalizes. Any face-like shape, babies instinctively have a preference for. We'll see more about this later, but one other subtle technique is to look at which toys they prefer to play with after showing them a puppet show. So I won't say it anymore, the video is pretty self-explanatory. This is done by Paul Bloom, who's the same guy who gives the lectures in that video playlist I have linked to in the syllabus. Used to be at Yale, now he's at Toronto. Okay, I'll stop there. Okay, now something I want to mention, so you'll hear that the researcher said, oh, that was the nice guy or whatever. I don't know about the specific study, but they have done it where the person showing the two toys doesn't know which one was the good guy and the bad guy, and they randomize shape. So sometimes the triangle is the mean one, sometimes the circle is the mean one, like for different kids, just to control for that as a confounding variable, and you get the same pattern, seeming to indicate kind of proto-moral tendencies in babies. Okay, with regard to babies' perceptual abilities, vision is the one that takes the longest to reach full capacity, but hearing is very good very early. Babies are good at detecting very subtle differences in sound. When they start off, they can detect differences between more phonemes even than an adult can, and as I mentioned in chapter 9, there's a use it or lose it principle. Right? If you don't hear certain sounds, you will lose the ability to distinguish them as you develop. Okay, some boring physiological findings. So as the human body develops, there are two general principles. One is, and is listed in the key terms, the cephalocaudal principle, and the other is the proximo-distal principle. Cephalo means having to do with the head, and caudal means like tail or rest of the body. And the idea there is the head develops first and the rest develops more slowly. So if you look at babies, they have large heads relative to the rest of their body compared to an adult because more development has gone on there and the rest will take longer, at least to physically develop. And proximo-distal means things in the center of the body develop faster than things on the outside. Proximo means like middle and distal means like further away. And going back to the cephalocaudal principle, when you are born, you already have almost all of the neurons that you will ever have. Brain development is not generally a process of new neurons being created. It's about new connections and about losing connections. There's an idea called neural Darwinism. Which is an account of how the brain develops that is modeled on Darwinian evolution. The way evolution works is, there's lots of random mutations, like random changes, and if the changes are harmful, that lineage will die out. But the ones that are suited to the environment, those genes increase in frequency over time. Something similar is true in the brain. What the brain does is it grows more connections than it needs, and it loses the ones that don't get used, the ones that are not useful. So it's sometimes called growth and pruning. So you grow more connections than you need and lose the ones that you don't need. Another process that's relevant to motor development, it's not in the key term, so I won't test you on it, but is myelination. As you may remember from 104, the axons that send signals to other neurons are covered with myelin sheath, which make the signals go faster. And myelin sheath is something also that grows a lot during motor development in babies. So that's the end of the physical development section. There's an image with when babies crawl or stand or things like that. I'm not going to say too much about that. I will just mention that my mom has told me that I did not do this normally. Apparently I was a very fat baby and I could stand and walk before I could crawl. When I was still supposed to be crawling, apparently I would just roll. I would just steamroll around because my arms could not lift my body off the ground. So I was an outlier, but the book has a brief discussion of the standard way of going through things. Any questions about the physical development stuff for babies? Okay, so next we'll talk about cognitive development. So development of thinking. And the big character here, the big kahuna, is Jean Piaget. And it's Piaget, not, if you want to really irritate a developmental psychologist, just tell them like John Piaget or something. They will not be happy about it. So Jean Piaget. Jean Piaget thought of babies as almost little scientists. They're kind of developing new ideas or new methods and testing them out against the world. In the early stages, this is relatively simple, but the process continues until they're around puberty, at which point they are more full-blown little scientists. They can actually use logic, hypothetical thinking, and so on. But even at the beginning, he kind of thought of them as little scientists. And he thought there were three basic processes. Schema creation, assimilation, and accommodation. So in chapter 9, we saw that a schema is a concept that helps you to organize information. Piaget means it a bit more broadly, such that it includes behavioral patterns. So it's sort of any way of interacting with the world. So both thinking patterns and behavioral patterns. So sucking on a pacifier for Piaget would count as a schema, but so would mental representations of the world that emerge later. So very broad term. So it's just a way of interacting with the world. You can think of it like that. So babies develop new ways of interacting with the world as they grow up. Assimilation is when you add something new to a schema. And it kind of goes in easily. So suppose a kid learns the concept dog, the schema dog. So they learn what a dog is, and then they see a golden retriever for the first time. And they go, oh, like that's a dog. And then that very easily fits in with their concept of dog. Accommodation is similar, but it requires that the schema be changed or modified in order to accommodate or in order to let in the new data point. So the kid learns the concept dog, but then he doesn't see a golden retriever, he sees a poodle or something. Some really weird, not prototypical dog. And he says, Mommy, what's that? And she says, oh, that's a dog. Huh. Has to kind of change his concept of dog in order to accept this new kind of strange example. So those are the three basic processes. And as kids use these processes, they go through Piaget's 4 stages. So Piaget thought there were 4 stages of development, all of which include these, but this is how it kind of works out as the kid gets older. Any questions about these before I erase them? Sorry. So the first stage is the sensory motor stage, which is about 0 to 2. So meaning before there's much language going. So in this stage, babies are primarily interacting with the world through their senses and through their bodies, like moving, grabbing things, putting things in their mouth, whatever. They don't have rich concepts yet. So they're just kind of experimenting with the world in a very physical, sensory kind of manner. Piaget thought there was one thing that developed kind of in the middle of this stage, at around 8 months, which is the concept of object permanence. That's one of the first concepts to develop according to Piaget. Object permanence is the understanding that objects continue to exist even when you do not see them. So I take this felt, put it behind my back. Hopefully you all understand that it still exists even when it's behind my back. And Piaget thought that young babies, before around 8 months, just didn't understand this. This was his explanation for why peekaboo is kind of surprising to kids. Because you cover your face, and as far as the kid's concerned, he's gone. The face just no longer exists. And then peekaboo, the face has come back. Very, very surprising. As we'll see later, some have challenged this and alleged that babies have object permanence earlier than Piaget thought, but in his model, it starts at around 8 months. The next stage is the pre-operational stage. Actually, I'll write all of them, so this will help me get the order right. So pre-operational obviously means before operational. And then these are the two operational stages. And formal you can think of as meaning more fancy, like more advanced, which is essentially what it is. Pre-operational is around 2 to 7. Concrete operational is about 7 to 12. And formal operational is 12 plus, give or take. So during the pre-operational stage, language develops. So this is when babies start to babble and try to talk, which allows them to have now concepts about things. More than just seeing and behaving, they actually are capable of thinking in more abstract ways. But there are some shortcomings. One shortcoming in the early part that kind of gets fixed about halfway through is egocentrism. And egocentrism here does not mean being selfish. I mean, yes, babies and toddlers are selfish. That's not what it means here. Egocentrism means you do not have the theory of mind. X means you do not have that. Theory of mind is the understanding that other people have different minds than you do. They have different beliefs than you do. There's things you know that they don't know, and things that they know that you don't know. And kids have difficulty with this. They can only really see the world through their own eyes. They have difficulty imagining being someone else. So here's a classic way of testing this. So you have a box and it's labeled Smarties. You show it to the kid. Hey, what do you think is in this box? If the kid is 3 or 4, so he hasn't quite hit 4 or 5, which is typically when theory of mind becomes better, the kid will, well, forget what I just said. This part actually doesn't matter. So first you ask him, what's in the box? And the kid will say Smarties. Not very surprising. But then, so let's say the kid's name is Bob. So Bob said, I think there's Smarties in there. But then you open the box, there's actually pens inside. And Bob's like, you tricked me. So okay, now there's Jimmy. You close the box up, Jimmy comes in. Jimmy hasn't seen any of this. He didn't see the pens revealed. And you ask Bob, what do you think that Jimmy thinks is inside the box? And the right answer is Smarties. Like, Jimmy's gonna think Smarties. He doesn't know there's pens inside. But what Bob will say, is in the early part of this stage, is pens. Jimmy thinks there's pens inside. Because he can't imagine what it's like to be someone else who doesn't know everything he knows. In other words, he doesn't have a theory of mind. And theory of mind is something that tends not to develop as well in autism. One of the main symptoms of autism is continued difficulty with theory of mind. cardinal symptoms. Okay, next I have to talk about conservation, but there's not much time left. I'll just say one other quick example is, you know, you have like dolls, and there's like, you know, box A and box B, and you show the doll putting their ball here, and then the doll goes over here. So this is the doll that put the ball here. And then a new doll comes in and moves the ball into B. And both the boxes are closed. You can't see inside, you have to open it. This doll comes back, and you ask, where will this doll look? And again, the kid will say here. Even though the doll wasn't around when the ball was moved, again, they just can't imagine that someone else doesn't know everything that they know. Okay, any questions about what I've said about Piaget's stages? Yeah?
Does that relate to also not understanding the hypothetical?
Not understanding what?
The hypothetical, like,
No, that's later. Doesn't relate to that. She said, does it relate to the hypothetical? Right? The answer is no. Yeah. Years. These refer to years. Okay, we'll call it a day there. So we'll start with conservation next time.